Hi, this is Nalini Elkins with Industry Network Technology Council, and today we're going to do the IPv6 lab, or the structure and function of IPv6 addresses. This is for the basic things that we learned last time about link local addresses, global unicast addresses, and multicast addresses. If you want to follow along, one of the things that you might do is on Windows, bring up a command prompt, on Linux, a terminal window, and so forth. If you're on a phone, you can install that Net Analyzer app, and you can try doing some of the commands that we're talking about. So otherwise, just follow along, and you will have the recording ready for you. This is a collaborative project between Industry Network Technology Council and the India Internet Engineering Society, IIESoc. And the funding for this is a generous grant from ISIF Asia, which is a part of the APNIC Foundation. Thank you so much. And here are our websites if you want more information. You can always go up to those websites also if you want the recording of past presentations or the foils. Feel free to ask us any questions, of course, but you can always get that. So what is our vision for IPv6? We want to, of course, get everybody trained, but then we want to start moving people toward deployment. We also have a collaboration with the American Registry for Internet Numbers, or ARIN. And so it's a three-part vision. First, to provide training, and then start looking at some really big problems which you may have, which are security and application. And then thirdly, to help enterprises plan their deployment. As you can see, this is a multi-year effort, and we're doing parts of 1, 2 right now. We're doing a little bit of 3 with some very selected organizations. If you're interested in that, do please contact us. This is the set of classes that we're doing. We've done the first one, and today we are doing the second one. I'll just tell you just a very few words about me, and then you've got this here to look at. Basically, I have many years in the industry, a lot of it doing network diagnostics, performance, and so on at large brick and mortar enterprises. You may be interested in RFC 8250, which is embedded performance and diagnostics for IPv6, which I wrote with Mike Ackerman. He's my co-author there, and he is the co-presenter on this lab, on this lab effort. And Mike is the lead network engineer at Blue Cross Blue Shield of Michigan. For the people who are out of the United States, the Blue Cross companies are one of the largest healthcare insurers, private, in the United States. Mike has had experience in all different aspects of network planning, engineering, deploying, administration. He loves Wireshark traces and does a lot of diagnostics. He's also chief architect for many plan-related IT issues. In fact, we met many years ago when the Blue Cross companies were thinking about IPv6, and we worked together on those projects. Mike is also a member of a number of advisory boards and active in the IETF and INTC. So one thing I might suggest is, if you're having trouble following along with some of what we're saying, you might want to review the presentation from last time, where we discussed the types of addresses and prefixes and so on for IPv6. It's really important that you understand IPv6 addressing, because otherwise the rest of it becomes quite confusing. So we're going to get into the hands-on sessions now. And so keep these questions in mind as we go along. Do I have an IPv6 address? That's what we're going to try and find out. What is it? Why do I have so many? And so on. That's the idea of what we're doing. Again, go ahead and review. Here's the past webinars. So Mike, I'm going to turn this over to you to introduce a little bit about why you're wanting to be involved, in particular with the lab session.
Thank you very much, Nalini, and hello, everyone. My part of this is going to try to let you all know some of the experiences that I have, because I often listen to some of Nalini's webinars and some of the other wonderful information that she imparts to us, and then I go back all fired up and I go, well, how do I get started? And I think a lot of people are like that. I've heard from others. So sometimes it's not as obvious as you think, where to look and what to do or how to get started. So that's the main thing that I'm going to try to do, is that try to avoid some of the delays and consternation and frustration that I expressed and experienced for you guys, just by giving you some key commands and definitions and things that would have saved me a lot of time. So hopefully you'll have less dents in your head when we're through this session today, and follow-up questions at any time. We're looking forward to that, because we want to help everybody learn about IPv6 so deployments can go more quickly and more smoothly. And I think that's all for now. Back to you.
Okay, thanks so much. So we're going to go ahead and start bringing up some things live, and we'll explain what you're seeing. This would be a good time for you to go ahead and bring up your terminal window or net analyzer. So first, let's think. Let's figure out the very basic question. Well, do I even have IPv6 at all? So let's stop here. So I want to bring up a terminal window here at Excel, and then we can see if we can find that. So okay, so what I've done here, I'm on my Windows machine at home, and just on my laptop, I'm going to go ahead and type IPconfig. And I'll do IPconfig/A in a moment. Let me just do IPconfig so we can see what we've got. And then Mike and I will go back and forth and explain what we're seeing here. Okay. So first of all, you can see that I have a number of connections. I've got my local area connection 1s and 2, nothing pretty much there. And I've got my Ethernet, nothing pretty much there. Everything I have seems to be going over my wireless LAN or Wi-Fi. So Mike, can you talk to us about what we're seeing here in this whole Wi-Fi network? In particular, I've got so many IPv6 addresses.
Yeah, it can be intimidating. And if those of us that go back to our own machines in our own networks and see displays that have multiple adapters, and Nalini said we're only seeing one Wi-Fi adapter here. You might have 4, 5, 6, 7, or even more. So don't be intimidated by that. You just page through until you find the one that you want. In this case, it's our Wi-Fi adapter, and that'll be the case for many of you. But there might be some other logical adapters, or you might have multiple physical interfaces on that box. So don't worry about that. It's just showing you what you got. So what we have here is messy enough, right? Look at all those IPv6 addresses. So let's go through what some of them are. And I'm going to start near the bottom where it says link local IPv6 address. So that is a link local address, which means that can only talk on the local subnet. Thank you, Nalini, for pointing that. And it can't go past a router boundary. So that's why it's called link local. And that's used for a lot of basic functions, and you can leverage it for your own use as well. So now above that, we have several addresses that all start with 2601. And if you remember from the class last week and from a couple of Nalini's comments today, that means that that's a global unicast address. And you remember also that you can have multiple of those. And so we have a few, and then we have one that's marked temporary. And I'm going to talk about the temporary one really quick here. And that is something that was inserted a few years ago for privacy and security purposes. The other two addresses are static. They don't change. They're there all the time. This temporary one changes periodically, and that's something that you can set. You can even set the fact that you use it or not, and whether or not it's your preferred address. So if you want something that changes because you think that that will help you be less transparent to the outside world for whatever reason, then temporary address is something you might want to use. Some systems have difficulty when their addresses change all the time, keeping certain sessions up, so you may not want to use it on all systems. So the important thing for now is to know that it's there, know what its intention is and was, and that it changes all the time, and that's part of its inherent function. And Nalini, I'm going to turn it back over to you to see if you have to fill anything in on any of the IPv6 addresses that I've just talked about.
Thanks, Mike. You know what? I'm gonna go ahead and prime you with some questions that I think people may have. So one of the things that people get a little confused by in IPv6 is that we don't just have one address for this interface. In IPv4 we had only one, and so but now I've got 1, 2, 3, 4 addresses. So what the heck is going on, and why might I use different addresses for different functions?
Well, and we talked a little bit about why you might want to use the temporary address and what its functions are. Beyond that, you can add pretty much as many interface addresses as you want to a given interface. And you might do that because you want to have a different address for a different session with different remote hosts. You might want to do it for security purposes. You might want to do it for control purposes. And one other reason that we really need to be aware of is how these addresses are assigned. They could be assigned statically, so you might want to have something that you assign statically to a server for particular sessions. And then we also have, which is big at enterprises, is DHCP, could be assigned by DHCP. And then finally, unique and new to IPv6 is we have Slack, which I believe, and this is a question for you, Nalini, that was covered last week in the previous session.
No, we're going to cover it.
Okay,
next
then
time.
Great. Then I'll just say a word about it. It's a way to dynamically assign addresses, so people don't have to get involved, and you get an address automatically. So any of these are possible in the IPv6 space, and you want to use what's best for you in a given situation. And that may vary because you may have smaller, more dynamic devices such as IoT devices where Slack is the right answer. But for the preponderance of your addresses in your network, maybe DHCP is the right answer. So Nalini, I hope I addressed most of your questions there.
Sure. So what you're saying is that for example, for servers, I might want to have a static IPv6 address because I don't want it changing all the time. Or I may decide that I want to have one type of address that goes to the internet, and I don't care if that's exposed to the outside world. But inside my network, maybe to a business partner, I may want to have another range of addresses going there. Yeah, so that's good. Well, the other thing that I wanted to talk about a little bit too is this whole prefix thing. We had talked last time about prefixes and /64, but you can see that this 2601, 642, C Charlie 202, and so on, that this is repeated for all my IPv6 addresses. Maybe Mike, you can talk a little bit about how that's assigned and where that might have been coming from.
Yeah, so that's sort of the network portion of the address, and then the last 64 bits are called your IID, and that identifies the device. And that all assumes that you're running on a /64, which is kind of the default for IPv6. Now, where did these addresses come from, and why are they all the same for the first 64 bits? I'm going to guess that you have an ISP on this system, I might even have heard you say that it's Comcast. So these are probably all coming from Comcast. And so as these are routed across the internet, it's that network portion of the address that's going to be used to get any session information, any packets from point A to point B, whatever your point B might be. Nalene, did I?
Great.
Okay, back to you then.
No, yeah, no, it's perfect. Thank you. So a couple more questions then for you to explain. So I see an IPv4 subnet mask right here. So where is my IPv6 subnet mask?
Like I said, the closest equivalent to that is the prefix, which is the network portion, and so we can see that in the addresses above, and so that's a /64, and that's sort of the equivalent of the IPv4 network mask, and much like the IPv4 network mask, it's those bits that are used in routing, and the rest is used to identify the end station device.
Sure, but I'm not going to anything like, it's not, you're not going to see another entry here that says subnet mask. That whole concept of the length subnet masking is gone. It's just going to be,
That's absolutely correct, and a lot of people think that's a nice advantage and alleviates a lot of the confusion that was associated with subnet mask, and it allows for more efficient routing and more efficient and smaller routing tables and routers. And so that's, I think, one thing that all of us enterprises are going to like better about IPv6.
Yes, great. No, that's right. It's just a lot. Once you understand it, it's really a lot simpler. So let's move on for a little bit. Let's talk about the gateway address. So I'm used to saying 10.0.0.1 address. That's the thinking is my and so can I assume that this FE80 address is my router as well? And then how come it's not a 2601 address? So can you speak to that a bit?
Yes, I'll give that a try. And yeah, absolutely. What you just said is true. That is a link local address. So that assumes that the router is on the local link, which absolutely makes sense because I can't get outside of the local link unless I do go through a router. So that's fine. That is a link local address. And I think you have some commands coming up. We should be able to ping that and have contact with it. And if we can't, we got some serious problems. Sometimes you will see both. You'll always see a link local address there, and sometimes you'll see a global address as well. And frequently, when it's the local, when it's the address of the router, and it's a GUA address, a global unicast address, it will end in ::1. That's not a hard and fast requirement, but it's kind of like it was in IPv4, that a lot of times we make the first addressable unit other than 0 the router, and that just helps to alleviate confusion and helps you when you're doing diagnostics.
Great. Thank you. And so now let's go ahead and see if we can do some things. I'm going to flip back real quickly to the presentation and see if we've covered some of the things that we wanted to. So what we've been talking about is, do I have an address at all? Sure. So what if we know how we can do that? And why do I have so many? That's always a question that comes up. Be looking at that. Who gave them to me? Well, it could be, there's multiple ways of looking at it. It could be stateless auto configuration. It could be DHCP-v6, or in the end, too, it could be your ISP who's giving you the prefix, which gave that. We also looked at my the router address and see if we can figure that out. So you see, your IPconfig or IFconfig under Mac or Linux really gives you an awful lot of information. So here it is, so that you've got that to do. So now let's just see. Now that I've got my address, well, can I do anything with it? So let's see if we can do anything. And so what we'll do is we'll do some unicast pings first, and then we'll trace them and we'll do a multicast ping. So first of all, we'll go ahead and start with Googling something which we know has an IPv6 address, say like Google, and then we'll do some multicast pings and see what we get. So 1 minute here while I bring up my terminal window. Okay, so I have my terminal window ready to go. Let me clear the screen so that we can see it. The other thing I'm going to do is I'm going to go ahead and bring up Wireshark so we can trace what you're doing. Wireshark is free. It's open source. You can just go to Wireshark and do a download of it. I think it's wireshark.org. And it is absolutely wonderful because you can see the packets flowing. You can capture it as they go back and forth. So what we'll go ahead and do here is I have pre-built a filter so that it's only going to look at ping request and ping reply. So anytime we've got any of those going out, then we will capture them. And so I'm capturing on my Wi-Fi interface. So let me go ahead and start the capture, and then we'll go ahead and do some commands. And then, as I say, now Mike and I will then go back and forth and explain to you what we're doing. Let me bring up, I'll do a straight ping to google.com, and then Mike will give you some elaborations on how you can do that. So I go ahead and ping, and you can see that I'm getting a reply from an IPv6 address. Let's see if we captured it in the trace. Well, it looks like we did. Let's go ahead and stop the trace. Let's go ahead and see if we can move this up a little bit so that you can see the exact address going back and forth. So Mike, do you want to talk a little bit about what we see in this Wireshark trace here?
Yeah, and for those of us that are new to IPv6, and that's enterprises in general, this is all pretty exciting. Look at all that stuff that's out there, and I really didn't do anything different other than ping Google. One thing you can do, and this is sort of a preamble to the ping command, if you do an NS lookup or otherwise look at the DNS information, you'll see that Google has both a IPv6 address, and Nalini's going to do that for me, and a v6 address. Aha, there it is, both of them, the 172 and the 2607. Nalini just said ping Google, and it came back with only IPv6. What does that tell you? It tells you that that your operating system, and this is true across almost all platforms now, prefers to use IPv6. So those of us that haven't fully deployed it, we're just fighting against what the best implementations are, both in the platforms and in the networks. So it went out, it shows the IPv6 address, and you can see in the trace now that we went from our source address out to what we found out was now the address of Google, and Google responded. Note also that we're using ICMP v6, which is very similar, but exclusive to v6. Nalini, can you look at the terminal window again real quickly? And if you want, would you bring that ping command back up, and then also between the word ping and Google, can you put -6? Now Nalini is telling it use only IPv6, and now it'll get the IPv6 address again. She could have also put -4, and that tells it to use only IPv4. So you can control that, and that's just a little argument on the command. So you're still in full control of which protocol you want to use, but you can see they both work equally well. They both show up in the trace, and they're both very similar to both the way they look and the way they look underneath in the trace, which to me is always a wonderful idea, is to go and look in the trace and see what's really going on out there in your network. And it helps you to arrive at a very basic understanding of the protocols as well. So I think that's all, Nalini. Back to you.
Yes. So I'm going to do this. So what I'm going to do is we did the ICMP-v6. And so if you're wondering, how come I did my ICMP-v6, my ICMP-v4, and I didn't see it, it's because of the filter I had on. You can see that once I did the Google, it went ahead and did a ping request and reply to the IPv4 address. Of course, you have to watch your filters, right, with Wireshark, because in the beginning, I had only said, get me the v6 ones. ICMP and ICMP-v6 are different. You know, we'll do quite a bit more on that in future sessions. A lot of what happens in IPv6 happens with ICMP commands. ICMP-v6, I should say. It's a lot more than we used to have in the IPv4 world. Much of neighbor discovery, multicast listener discovery, and so on is all going over the ICMP-v6. What I'm going to do now is I'm going to go ahead and export these packets, and I'm going to save this. This is pinged to Google, IPv6 and IPv4, and we'll make those available to you as well if you would like them. And so that's another fun thing to have. Just to look at the tree. So let's keep going now. Let's do some more interesting things. So what we had done is we did a unicast ping. When I say a unicast ping, that means that I did it to one specific address. One of the things that we've been talking about is the whole idea of multicast and how multicast is used very, very frequently in IPv6. And so what we're going to do now is let's go ahead, a multicast address, and then we'll see what happens. So I put in here a ping to a multicast address. I put in FF02::1. So Mike, do you want to talk a little bit about what that address is and what we should be seeing in our trace if we did?
I'll certainly give it a try. And yeah, things are getting exciting now. So it's just a normal ping command, and then the FF means multicast. The next couple of bytes there, the 02, tell us the scope, and Nalini covered that last week. In this case, we're telling it to use the link local scope. So it's sort of like the local subnet. In other words, don't go out to the internet, or you could have restricted it in the other direction and say, just do it just on this interface. And then finally at the end, the ::1 is the group on the local link. And one says, contact all nodes for me. Now, Nalini could have typed 2, which is all routers and a few others. And I guess if we're really good, Nalini, she can tell us some of the more exotic or fancier scopes that we have other than 02, which again is just link local, kind of give me everything on the subnet. So
sure.
Go ahead, Nalini.
Yeah. So let's go ahead and try that. Yeah, let's go ahead and start it, and then we'll just take a look at what happens when we do that. And we'll go ahead and actually go up to IANA, where it's all defined. So so ideally what we should be doing here, this should be any node on this link should answer. And so what are we seeing here? So we're pinging with 32 bytes of data. If you don't put anything in there, like the number of times, he's going to try it 4 times. Well, so what's he telling me? He's saying, well, I can't get to anybody. Request timed out. So no one is responding. Well, let's see what happened in our trace. Oh my goodness. Well, he's lying to me. He's lying to me. Somebody did reply. So
character.
yeah. So Mike, do you want to talk a little bit about what we're seeing here?
Yeah, sure. And then this looks much more exciting. Again, an endorsement for using traces, because the traces will never lie to you. And sometimes commands and applications and displays can be misleading. And that's the case that we're seeing here. If you look at the very top, the very first trace entry right there, it says we're going from a link local address that ends in 59 alpha 0 to the FF02::1. Exactly what Nalini typed in. So that's saying, give me, I want to contact everything that's on this link that's a node of any kind. And we get, on the second line, we get a reply from a couple different ones before we repeat it and try it again. So there's at least two things out there on this link local interface that are responding to me. I don't know who they are. I can see their addresses. I can look at more up about them later, but I do know that there's somebody out there and that they're talking to me. Nalini, anything for you to add to that?
Sure. No, let's see if we can figure out who that is. So what Mike is saying here is, so we've got these other addresses and they did a ping reply, but look at what they've got. It's 125611FF E3D7. So that's not them. We think this address that ends in 5980, that's probably us right here. How do we check that? Well, let's go ahead and do our IPconfig again. And so, yeah, that's me right here. You can see that I've got this link local address that ends in 5980, and so that was me. But look here, I see another one. This thing that ends in E3dog7. Looks like he replied. That next one, that E3dog7, that looks like my router. So my router went ahead and replied to that. But interestingly enough, you'll see that the request up here, he says the request timed out. That's kind of interesting, huh? So that's an interesting thing. The next you'll see there's somebody else on here. Somebody else, 7F2B. Well, I wonder who that could be. That's somebody else on my network. So I'm gonna go ahead and do a little trace, and then let's see if we can figure out who that is. I'm gonna start capturing assets. I'm going to do something because I am pretty sure I know who that is. So I'm going to do this. So what am I getting here? So what I did right then is that is my phone. That is my phone. And I use that net, the Net Analyzer app. And from my phone, I did a ping to FF02::1. And you can see these ping requests are coming in to here. And so we should be seeing, interestingly enough, where's the ping replies? So we've got to figure out, there's a hold up to that question, because what we need to do in a future session is go ahead and go over the firewall rules and so forth. But as you can see, depending on where you are, if you do that ping to FF02::1, you might be able to see everybody who is on your link by doing that. Let's do a couple of other interesting things in here. We'll go ahead and clear the screen here. Go over to the bottom. Let's pinging FF02::2. So Mike, do you want to talk a little bit about what I'm doing here?
Why, certainly. This is very similar to the last command. It's a multicast. It's local in scope, and then : :1 is what we had before. Now we got 2, and I think I mentioned a couple minutes ago, that means give me all routers. So all routers respond. So let's see what kind of action we get on that.
Sure. Let's go ahead and start our trace. So let's go ahead and ping that. Let's see if any routers respond. Now, you know what? Again, I think he's lying to me because we know for sure we have a.
Yeah, he lied to us before, so let's assume he's lying again. And when he finishes there, I think he even totals up his lies. And he says, and by that I mean he says that we sent 4, which we know we did, and he says he received 0. But hey, look at this. He did receive some replies.
Yeah, 4.
And if we look, where is that reply coming from? It's that same E3D7. Now my memory isn't that good, but if we look in the IPconfig display, let's see. I'm hoping that's the router. It's our default gateway, and we mentioned earlier that that's pretty important that you're talking to your default router because otherwise you can't go anywhere. And so that's good news, in spite of the bad news that the ping command output told us.
Yeah. So that's an interesting thing that we'll have to work out. So let's do a couple of other things. We'll do some more interesting pings with different scopes, and I'll show you where to go on the IANA website to look for that. And then we'll go ahead and look at our neighbor cache. So we've done FFO2::2. Let's do FFO2::16, and you'll see why I'm doing that. Well, no, you know what? Let's do that. Let's do FFO5::1. FFO5 is going to be anybody at my site. So let's see if we can get anybody in our site to respond. Go ahead and start our trace. Oops. Sorry, I mean this. We want to continue without saving. Let's go ahead and do our FFO5 to see if we've got anybody at our site. Again, he's saying, nope, I can't get to anybody in your site, and we'll look at the trace and see if that's really true. Oh. Okay. This looks a little bit different. So, Mike, you want to talk a little bit about what this is looking like?
Yeah, the biggest thing that I noticed is the source address has changed from a link local address to a global address. Now, why is that? Aha, it's because our intention by FF05, it says, oh, I'm not going to just restrict myself to the local link. I'm going out to the whole site. So IPv6 is smart enough to know that a link local address can't go beyond the router boundary, so he substitutes that in there and sends it out. I also notice we're not getting any replies, and I'm not sure why that is, so I think we have some more work to do there.
Great, great. So let's just do a couple of more fun things, and then we'll go look at the IANA site. So you can also do ping to FFOE::1, and that is supposedly anybody on the internet. Now, you know, I can really see why people would block things like that. That seems like probably a good thing to do. So
just asking for trouble.
so here I go. FFOE::1. Yeah, as I say, it's not real clear to me why these scopes were done that way, but there we are, right? Okay, so let's look at our trace. And so you can see, let me stop this. Yeah, you can see again, we're going out over our global unicast address, going out to FFOE::1, and he's certainly taking that as a valid destination address. I mean, he's not coming back to me saying parameter problem or something like that. So he believes these to be valid valid scope, if you will. So let's talk a second. So let's go ahead. You could go up to the IANA website. You can go into the IPv6 Multicast Address Space Registry. And you can look up here. Here's the scope of the address. So 0 is reserved. 1 is the interface itself. Basically, you're loop backing. That's just you're talking to yourself. 2 is link local. That's what we did before, FFO2. And then we did FFO5, which is site local, and FFOE, which is global or internet scope. But there's also some kind of interesting one, FFO3. It says realm local. So I suppose if you're in the kingdom of Nalini, that would be your realm. That's an interesting one. Let's look also at some of the there's also, you can also find the ::1, ::2, and so on, and you'll see what those are. Let's do some of those in a moment. So let me do that. So what I'm going to do now is I'm ping FFO2 : 16, and I'll tell you why I'm doing that in a moment. So let's go ahead and start our trace. So I'm going to ping FFO2 : 16, and you'll see why I'm doing it in a moment. Because I saw that somewhere that I'm going to, and why would I do that? Again, we look like we're not getting it back. Go ahead.
No, I was going to say, we know we can't trust ping, so let's look in the trace and see what's really going on.
Yeah, and this time he's right. We're not getting anything back. And why would I be doing that anyway? So here's an interesting command. I'm going to do this I'm going to do a netsh command, and then Mike can talk a little about what is that command and why we're doing it and what it's showing you.
So what Nalini's typing in there is, first off, netsh has been a command in Windows forever, but I don't think many people used it. I didn't, but with the advent of IPv6, it becomes a pretty valuable command. You can do a lot of these things in the Windows graphic interface, but I think once you get used to this command, you can do it a lot faster, and there's a lot of things that you can do and change that don't require a restart, which is a very wonderful thing. So in this particular case, we're saying netsh, and we want to look at some interface parameters, which is the second thing she typed in there. We want to use IPv6, and we want to show something. And in this case, there's a lot of things we can show, but in this case, we're going to show the neighbors. This is an important command. Reason is that most of us are used to doing ARP displays. We want to know how can we get to these neighbors, and who's on the local link with us, or who's on the subnet, and tell me something about them. Can I reach them? So this one command will tell you everybody that's on there that you can either reach or not reach, and they've responded or they've not responded. So the show neighbor command is one that you can go back and use it on any of your systems. It's there, and just check it out and get familiar with it. I think there's a lot of good usable information in there, especially if you're going to try to do diagnostics or see what's going on your system or on your network. So let's walk through a couple of them. The display is down like where Nalini has the crayon or the marker there. And we have internet addresses. These are all multicast addresses. And then usually off to the right, it'll show the status or the type or some information about that. And these are all permanent because all the multicast addresses are virtual or predefined, and they're always going to be out there, and most all systems will be listening on these multicast addresses and groups. You see the interface name down there, and so let's, yeah, perfect. Let's move down a little bit. Now we finally see more of a normal address. We see a couple link local addresses, and we see one that's marked as stale. Stale means that he has talked to that device before, but right now that device is not active with him. A lot of times you'll see things become reachable, and then if you don't use them, they become stale real quick. So That's not necessarily bad or something to worry about. We don't know who that is, but you do see its physical or MAC address, so you can kind of look that up and find out more about it. I think Nalini has already done that and determined that that was her phone. Is that right, Nalini?
Yes, that was my phone. Yep, he had talked. It looked like the laptop had talked to my phone at some point, and it is now stale. And the next one here, of course, is the router. That is reachable.
Yep. So because we're always talking to him, and we just ping. So one thing you can do when you get really fancy with the neighbor display command here is a lot of times you'll display it, and they'll, like, everything will be stale and nothing's reachable. Do the multicast ping, and all of a sudden you'll see things come to life, and you might see 20, 30 or more things on your subnet that you didn't think were active or there before. So it's kind of an exciting command to work with sometimes. Nalini, I think that's all I was going to say about the neighbor display. You probably have some good stuff to add.
Sure. So what we did, we went ahead and did the multicast group, all nodes. These are all the multicast groups this guy belongs to. FFO2:1, we did that, all nodes, all routers. And so here's the 16 that we did. Let's take a quick look. Let's take a quick look at what that might be. Those are interesting to see. Let me hold up. Get back up to the IANA site, and then we can see. So here we are, and so what we're going to make sure that we're looking in the right place. This is the node local scope. We don't want that. We want the link local scope because we're looking at that one. And so FFO1, FFO2:1 is all nodes. FFO2:2 all routers. Looks like what's 16 there? 16 is all MLD v2 capable routers. That's multicast listener discovery, which we will go through in the next presentation. We also see here that we see FFO2:: Charlie and : FB. Let's see if we can figure out what those are. Charlie looks like SSVP, and then F Baker looks like multicast DNS, if I'm not incorrect. Yes, multicast DNS. A lot of times getting out to your printers and that, a lot of times you'll use multicast DNS to get out.
And let me say the takeaway here is that there's a whole bunch of those things, isn't there? And a lot of them won't come into play sometimes. So keep this link handy, if you will, or whatever your favorite way to find where this information is, in case you do run into one where it does matter, and then you can look it up, just like Nalini just did when you see for instance, the FB there, and you wonder what the heck that is. There it is, multicast DNS for version 6.
Great. Well, so let's wrap up. We've been going for a long time, and we can talk. Mike and I can do this for hours. There's something really wrong with us. And so let's finish up. We've got more information, the appendixes, and to have commands and examples. And so you've got all this stuff available for you. You have the recording. Stay connected with us if you have questions. We'd love to hear from you. The next presentation will be the neighbor discovery presentation, and then we'll start going into what do I really mean by Slack? What is that? And we'll follow that by a lab on neighbor discovery. That's coming up here in March. As a next step, help us plan the topics that we might want to address. And then as far as enterprises and universities are concerned, we have calls for participation to work with. One enticement for enterprises is please work with us. And if you do that, we'll help you start planning your IPv6 deployment. I hope you feel like that is a sweetener. So please work with us. Please contact us with any questions. And let me wrap up. And Mike, thank you so much for your help. And you'll see us again when we do the neighbor discovery lab. So thanks again, And I will go ahead and stop recording now.